Hi, my name is Alfred Mosai and I am a math teacher. Welcome to my lesson. Today's topic will be differentiation. Before we talk about differentiation, we need to review some previous topics, which are, first of all, you need to know the linear equations and their gradients. You need to know quadratic equations and their graphs. Also, you need to know the graphs of some special functions like cubic functions, rational functions, and trigonometric functions. So, let's go on. What is the gradient of a tangent to a curve? First of all, we need to review one more time what is a gradient and what is a tangent line. A tangent line to a curve at the point P is a straight line that touches the curve only at once at the point P, for example. And also, definition of the gradient of a line is the ratio of the change in height by the change in horizontal distance. For example, as we see here, we have given two different definitions about the gradient. We can find the gradient by using any 2 points of the line, the point P and the point Q. The point P is x1, y1, the point Q x2, y2, and we can just do the difference of y's, y2 minus y1 over x2 minus x1. Or we can find the gradient by the change on y over change on x. Or we can call the change on x, we can call like run, the change on y we can call like rise. And their ratio, rise over run, will give us the gradient. Those are the key topics or the key definitions that you need to know to understand better the differentiation. So, then the gradient of a curve at the point P. As we see here, we have a curve colored with blue, and we have a straight line, which is tangent to the curve at the point P. As we said, we can find the gradient of the curve by using two different methods, by using any 2 points given here, or by using the ratio of difference on y or change on y over difference on x or the change on x. Since this tangent line at the point P is like a straight line, as you see here, we can say that the gradient of the curve at the point P must be equal to the gradient of the tangent line at the point P. So, to find the gradient of the curve, we need just to find the gradient of the tangent line around the point P. For this, what we need to do, we just need to take any 2 points around point P, then find the normal gradient of the tangent, then it will be equal to the gradient of the curve at the point P. So we can say that the tangent of the curve is the same as the gradient of the tangent line if I take any 2 points like given in the figure. But we need to be careful because not always we can find an exact value for the gradient, because it is difficult to draw an accurate straight line. We need to be very careful to draw the tangent line here. We can use, to draw it better, we can use the different millimetric papers that can help us to draw an accurate straight line. So don't worry if you find different values of the gradient of the curve, because this depends on how accurate you can draw the straight line. So we can say that we cannot find exactly the exact values sometimes, but we can estimate the gradient of the curve. And this happens because you cannot draw an accurate straight line always. Let's see an example to understand it better. Estimate the gradient of a tangent to the curve y is equal to x minus 2 squared at the point 4, 4. We need to follow some steps to the gradient of the tangent to the curve. The steps are, first of all, we need to sketch the graph. we can see that this graph is a quadratic equation, quadratic function, and we need to know, and we have learned before how to draw a quadratic function. I have drawn it for you. I have used the Desmos graphics. You can find it online, and you can use also by writing the equation on the Desmos. You can draw this graph, and it can help you because it uses these squares. It can help you to find better what is the gradient of the tangent line. After that, we draw the tangent line at the point 4, 4, like it says on the question. We draw the tangent line with black. Then we pick any 2 points on the tangent line around the point 4, 4. We can find any 2 points, but we try to find exact points like I have taken here and here. Also, I can take any other 2 points here and here, but I try to use exact values like here. After that, I draw a right triangle from the tangent line and 2 points that I have taken here, and I can count the squares here to find the change on x, and to the other side to find the change on the y-axis. As we see here, the change on the y-axis is 8 units or 8 squares, because we accept these squares are 1 unit, and the change on x-axis it will be 2 units. To find its gradient, we just need to do the ratio as we give in the definition, change on y over change on x, and as we said, change on y is 8 units over change on x, which is 2 units, and the gradient will be 4. So let's go to another question. Y is equal to x squared plus x minus 2. First question says that use the scale of 1 centimeter to 1 unit to plot the graph of y is equal to x squared plus x minus 2, for x is between 3 and minus 3. Estimate the gradient of the tangent to the curve at point 2, 4, and estimate the gradient of the tangent to the curve at the point minus 1, minus 2. We need to follow again the steps that we gave in the previous question. We need to sketch the graph, which is the same as the first question A here. Then we can use again the Desmos graph to sketch the graph. Then we pick any 2 points around the point 2, 4 on the tangent line. We try to find exact values as we said before. Then after that we draw a right triangle from the tangent line and these 2 points that we just took here. Then we find the tangent by counting the squares here. We see that the change on y will be 10 small squares and the change on x will be 2 small squares. Then we can answer the question B here to find directly the gradient, which is the change on y over change on x, and we can find it 10 over 2 is equal to 5. On B, it says that estimate the gradient of the tangent to the curve at the point minus 1, minus 2. We need to follow the same steps. We sketch the graph. We sketch the tangent line on the point minus 1, minus 2. We take any 2 points around the point minus 1, minus 2. These 2 points we can call A and B, and we count the square. We see that the change on y-axis, it is minus 4 here, because we see that the line goes downwards, and the squares we need to start counting from here. 1, 2, 3, 4. Since it goes downwards, we can say it minus 4 units, and here we see that it goes in positive direction, 4 units again. Then following the steps as we said, we can find the tangent of the curve, just the change on y, which is minus 4, over change on x, which is 4, and this will be equal to minus 1 again. Let's go to another question. As we see here, the grid shows the graph of y is equal to x cubed minus 3x plus 1. This is a cubic equation or cubic function. Then it wants from us to estimate the gradient of the tangent to the curve at the point where x is equal to minus 1, 5. First step is just find the point -1, -1.5 here, which is around here, and I draw the tangent line, and I pick 2 points around the point -1,5, x -1,5, which is this one here, and I see that, as we said before, we cannot find maybe exact value, but we can round it, or we can estimate the gradient of the tangent. We see that the point A here is around 4 here, and the point B here is around 1. And if we count the squares, we have approximately a complete square here. So we can say that the change on x-axis is 1 unit. And we see here then we have approximately 3 squares. Say that the change on y-axis is 3 units. Then we can just use the formula again, change on y over change on x. And as you see, change on y is 3 squares or 3 units. Change on x is 1 unit or 1 square, and it is 3 over 1 equal to 3. Question B says that write down the coordinates of the points on the curve where the gradient of the tangent equals to 0. The gradient equal to 0 means that we need to have 0 divided by something. 0 divided by something. We cannot have a number divided by 0 because this makes the expression undefined. That's why we need to have equal y values. That's why we need to see where the tangent line is a horizontal line. So, as we said, the change on y-axis must be 0, which means a must be 0 of change on x-axis, which is equal to 0 again. And we see here that the tangent lines can be drawn horizontally only on the point x is equal to -1, which is this point here. And if we draw the tangent line and pick any 2 points again, point A and point B, the coordinates of the point A are -2, 3, and the coordinates of the point B are 0, 3, then if we find the gradient, it will be 3 minus 3 over -2 minus 0, which gives us equal to 0. Again, in the same logic, we can draw another horizontal line at the point x is equal to 1, at the point 1 minus 1. So we see that if we find any if you take any 2 points around the point 1 minus 1, we can take the point C and D. The coordinates of point C are 0 minus 1, and the coordinates of point D are 2 minus 1. If we do the ratio, or the y2 minus y1 over x2 minus x1, we see that it will be 0 over -2 equal to 0. As we said, the gradient is 0 always if the line is a horizontal line, means the y coordinates are the same, such that gives us the ratio 0 over the change on x-axis. That's why the only points where we can draw a horizontal line is the point -1, 3, and the point 1, -1. Thank you for watching me on this tutorial. So don't forget to subscribe me on the social media platform.